Hello, everyone. I'm super excited to be at PyCon US 2021. Thank you so much for joining in. I'm going to be talking to you about reproducible and maintainable data science code with Kedro, so stay tuned. I guess it's always good to know who's the stranger on the screen that you're talking to. My name is Yetunde Dada. I am a principal product manager at a company called Quantum Black, which is part of McKinsey & Company. I'll get into a bit more detail about that. I'm one of the maintainers on Kedro. It's an open source project and part of an amazing team. I really think there's lots of ways to reach out if you want to get into contact with me. I talk about Kedro all the time because I'm really passionate about it. In my old life, I actually would have been a user of Kedro when I used to build data pipelines and worried about the reproducibility of my work. But now on the other side, it's great to be able to build products that help people that do so. When we talk about what Quantum Black is, it's an advanced analytics company that was acquired by McKinsey a few years ago. Our official wording is that we're the machine learning and AI center of excellence for McKinsey. But I really like to think of us as the Black Ops team, dirty data, disparate data sources, large scale machine learning products that need to be built with many collaborators. And our origins are actually in Formula One, where our co-founders met each other and realized that they could take some of their learnings of applying advanced analytics to Formula One into the business world. But today I'm actually going to talk to you about what is this problem that Kedro is trying to solve. What is Kedro? And we're going to talk about that whole workflow of converting a Jupyter notebook into a Kedro project. So in terms of framing, it's always handy to understand really what is your end goal. Are you writing code all the time that you're sure that no one is going to use after your project is complete? It's kind of used for some sort of like business decision or report. And that's you can run it on your machine kind of if you make it work a little bit and jiggle it. But it's kind of like no one is expected to use this code because in those cases, it's perfectly fine to optimize for speed. You're optimizing for speed. In the case of this building over here, you can see that it works. This is not very robust. It does what it's supposed to. But sometimes what happens is your business stakeholders or team members get really excited about the insights and they ask you to take it to production. And this is where you should have been thinking about creating something that looks like this, a machine learning product, which we call data science code that needs to be rerun and maintained in future by someone or a system. And in these two examples, you actually see that we need to completely flatten that shed and rebuild this building because we can't use any of that code base because of the way that it was rewritten and structured. So we start to go into some of the reasons why it's so hard to write code like this all the time. Because I mean, we love experimenting with our code bases, right? And one of the issues lies with our reliance on Jupyter notebooks. So we really believe that Jupyter notebooks are really good for exploratory data analysis, initial pipeline development, and reporting. But in terms of building your whole pipeline or workflow in it, you run into a few challenges, which we've called the 5 C's of challenges. So the first one is collaboration. How do multiple people work on the same Jupyter notebook together? There are a few ways to get around it, but it's generally not built for it. How do you do efficient code reviews? How do we make sure that we're improving each other's code as we're using a Jupyter notebook? We talk about code quality as well. How do you think about writing unit tests, or documentation, or doing code linting in those cases? What happens when you've heavily relied on Jupyter Notebook's ability to help you with cached state and now have to run your Jupyter Notebook from start to finish and realize that actually it's not working as it should because you've got some hidden state in your Jupyter Notebook. And really the final C is, I guess, a representation of all of these things is consistency. So NYU in 2019 conducted a study where they took 860,000 notebooks found in over 260,000 GitHub repositories. 24% of those notebooks ran, and only 4% produced the same results. So we start to see some issues around reproducibility when we rely solely on Jupyter notebooks for our workflows. But let's say you've actually moved on. You're relying on Python script, you're using linting, you're using all these amazing things. And now you start to find a different series of challenges, primarily that everyone works in different ways. You can't go across your organization or your unit and work on someone else's project because they've just set it up in very different ways. You have to learn so many tools to do this as well, and it's constantly growing in this space. You all have different levels of software engineering expertise in your organization as well, or in your academic field. And you need higher levels to produce high quality code. And this is where we understand that machine learning is definitely not the hard part. You know this. Building and maintaining the data and machine learning pipeline is. So what is Kedro? Kedro is an open source Python framework that was developed and maintained by Quantum Black. It's also McKinsey's first open source product. And it helps us produce reproducible, maintainable, and modular data science code. It does this by borrowing concepts from software engineering. So things like modularity, separation of concerns, and versioning. And we use it to address the shortcomings of Jupyter notebooks and Glue code. We also use it because it increases the efficiency of an analytics team. And the way that we're using Kedro now is actually to build reusable code stores, kind of like how you would use React to build React components to build design systems for your front end. We're now doing that with machine learning code with Kedro. It's kind of making headway in the MLOps space, winning different awards, and it's of course being used all over the world at startups and major enterprises in academia. You can check out the growing list on our README on GitHub and see which companies feature there. I'm going to lightly talk about some of the concepts in Kedro, but we'll actually be covering them in the preview or demo that I'm going to be running. So we talk about our project template, series of files and folders. If you're familiar with a tool called the Cookie Cutter Data Science, it falls within that remit. We talk about removing hard-coded variables from your machine learning code so that it can run locally or in the cloud or in production without major changes. We talk about our data catalog, which is extensible collection of data, model or image connectors that allow you to connect to any cloud storage or production system and borrow arguments from things like Pandas, Spark, Matplotlib, you name it. And then I'll also talk about our pipeline abstraction. So if we think of Kedro kind of in the example of those buildings as the scaffolding for a project, then we can look at, obviously that supports how you write code that you're proud to deploy. So Kedro obviously has many different deployment modes, so it fits into many different ways that people work. So obviously supporting a range of tools, including Databricks or Kubeflow, AWS Batch or AWS SageMaker or Docker, whatever you need to use. And we really do think of like, is Kedro an orchestrator? No, because yes, we do have a pipeline abstraction, but we can convert it into a pipeline abstraction that belongs to an orchestrator. And that's what we prefer to do. Because things like, what time will my pipeline run? How will I know if it failed? What will it retry if it failed? We leave to things that are really good at that, like Apache Airflow, Argo, Kubeflow, Prefect, and many more. And really, Kedro focuses on things that they're not good at, which is how do I write standardized, modular, maintainable, and reproducible data science code all the time. And that's what we do. You'll find us online as well. The Kedro community is growing. We have Kedroids all around the world, building amazing plugins and showing us how to do things. You can find us on GitHub, you can find us on Discord, Stack Overflow, read the docs, and soon Discord. So right now I'm going to actually jump into converting a Jupyter notebook into a project and actually briefly take you through an example of how you could possibly think to attempt this. So what I'm going to do is share this and in show, and here we go. So here's an example of what one of those GitHub repos could look like. I'm going to take you through the issues that are wrong with it. So we see over here, we've got some README. Someone tried to explain to me this example, the context of this example. So the context of this example is that it's the year 2160. There are many companies flying people to the moon and back. Space tourism is booming. And you are trying to predict the price of a space flight. And you have access to 3 data sources: companies' information, shuttles that are owned by those companies, and reviews of people that have ridden on those shuttles. And you now have to predict the price of a space ticket, essentially. You want to split your workflow into 2 parts: data pre-processing and then some sort of data science or modeling workflow. In this case, we already see we have our data sources here. So this is a very unstandard workflow in the sense that enterprise data science is should not be done like this, where you have full data committed to a Git repository. And also, normally your data sets are so big that this could never happen anyways, right? So in this case, working with local folders, so this is why my data is here. We also see someone tried to explain to me that I need sklearn version 0.2 or above installed to try and get the same results. And I really wish they told me the exact version to install in case like I wanted to reproduce the same thing. If I open up the Jupyter notebooks here, we see my import statements here. Yeah, that's great. You tell me to read CSV. I see this company's table, total fleet count. This is the company location, company ID. Great. Oh, someone deleted something in my Jupyter notebook. Oh no. I see that is_true is not defined because I didn't run state in order. Once again, I have another import statement here. I'm not sure why I did this. And eventually I output something to a CSV. I do the same with my data science workflow. This one's a little bit better. So my import statements at the top. I've tried to write in Python functions. This is great. I see another import statement here where I could have done a little bit better, but the data science workflow is not good. But you also see I have some interesting naming for my Jupyter notebooks, because when we talk about how could we improve this workflow, we're going to be refactoring in stages in this exercise. Let's go to have a look at what's changed. So all my data has been moved into a data directory. I've moved it there. All my notebooks have been moved into a notebooks directory. My notebooks have been renamed. They can now run start to finish. All workflow uses Python functions and all functions have been grouped. And logic for loading and saving data has been separated. So let's have a look. We see over here my import statements at the top. It's good. I clearly demarcate where I'm loading data. I have some helper functions that I'm using, so I specify them here. I have my main functions to run, pre-process companies, pre-process shuttles, and create a model input table. And then I run everything. And then I save my data. I do the same with data science in the sense that we have my import statements at the top. I load my data. I have some data science parameters, including things like the names of the columns that I'm interested in the model input table. I import things like my parameters into the different functions that I'm using. And then I run my workflow, and then I save my model at the end. So looking much better, right? It could get even better, and here's where we leverage some of Kedro's functionality. So now I introduce configuration to you. We have this new thing called the conf directory. So over here, we see we've introduced conf, we've removed loading and saving paths for data, and we have data science parameters now also out of our workflow. So what we see over here is obviously configuration. We see we've introduced this conf directory, and let's have a look at what's inside it. So there's a file called catalog YAML. This is Kedro's data catalog. It manages both the loading and the saving of data. And you see it uses common integrations like pandas. You can use Spark, you can use Dast, you can use Matplotlib, Plotly, or anything else. Kedro really considers these as connectors, kind of like to whatever data source that you're looking for. You have to specify a type. In this case, I know I'm going to be using the pandas API to read a CSV data set. And then also I'll tell Kedro exactly where this file is stored so I can interact with it in that way. I can do the same with the Excel, for instance, reading Excel spreadsheets. The shuttles table was an Excel spreadsheet, so I have things accordingly. But I can even interact with things like Pickle, which is quite cool. If you're using the data catalog within the framework, the Kedro framework, so not just as a library as we are using it now, then you actually get things like versioning on top of your workflow as well, which is quite cool. Let's have a look at parameters YAML, which in this case over here, we've got essentially that block of parameters that were in our second example in our refactoring have now become just parameters here that we can use. So let's actually see what happens, what changes happen in our Jupyter notebooks. So we see over here, we now import a config loader from Kedro, as well as IO to specifically interact with our data catalog. We tell Kedro where to find our configuration in this place, it's conf. We tell Kedro we're specifically looking for the catalog YAML file so that we can create our data catalog. And this is how you interact with loading and saving data in Kedro. It becomes as simple as a catalog.load companies, and Kedro knows to use the pandas API to load the company's table from configuration. If you were using Kedro natively in within the framework and using a command called Kedro Jupyter Notebook to open up your notebook, your Kedro version of the Jupyter Notebook, all you'd need to do is specify this. You wouldn't have to specify any of this because we take care of that knowledge for you. So your workflow simply becomes catalog.load. Everything else remains the same. And when you need to save stuff, you just use catalog.save, and Kedro's data catalog will take care of the loading and the saving of data for you. If we look at how the data science workflow changed, we'll see something similar happened. So tell Kedro where to find configuration, how to load our data set as well that we're interested in. And then in this case, we're interested in parameters. So we get our parameters using a dictionary format from our conf loader. And then nothing else, everything else stays the same. So this is the second stage refactoring. So I'm actually just going to show you how easy it is to create a new Kedro project template and start like this from the beginning. We're just going to go Kedro new, let me run that. And it'll ask me for some name. I'll just say this one is PyCon demo. I'll accept the default naming by pressing enter. And when we have a look at our new folder structure, you'll see that we have a new folder structure. This one has the conf directory, data, docs, logs, notebooks, and source. I'll go into what all of those things do. But essentially, yeah, this is the start. A project template, I mentioned series of files and folders. It's modifiable. It's got built-in support for Python logging, for PyTest, for unit tests, and strings for documentation. It means that you can spend time on documenting your ML approach and not how you structured your project. And then you spend less time digging around in previous projects for useful code. And it's also easier for other collaborators to work with you. So that's why it's useful to have that. But let's actually go into for Kedro space flights. So I'm just going to copy the path for this one. Cool, I'm in it. So let's actually have a look at how configuration has changed from 03, which was single directory with catalog and parameters. In this case, we now have a conf directory that has, in a typical Kedro project, just base and local. Base is project shareable configuration, which you can use across your team. And then local would be things like your VS Code, like config. You don't want to really share that with anyone else, so you'll pop that in this folder because it's getting ignored. So if we're going to base, you'll see the same catalog.yaml is right here. It's the same one. Parameters.yaml is also the same. And we also have configuration for logging as well. This is generated for you automatically. It's not something that you have to do, and it gives you Python logging control for free. You can modify this file if you want. It's really useful to have configuration because I mentioned with that same code base, even with our notebook example that we had in the previous example, I could change the path to the configuration that I'm interested in and run it with, maybe my data wasn't on my local computer. It was on S3. Maybe it was a SQL table or a SQL database that I was interested in. Maybe it was on Google Cloud Platform. Having this flexibility means that I could easily do something like Kedro run with my base configuration with whatever files on my local computer. But if I add, I'm really interested in doing a Kedro run with my production version of my code base, it's very easy to transition to that right now. Same code, different config. I'll talk next about data. So in most cases, enterprise data science I mentioned does not have data stored on the local computer, but you will note that we have a data engineering convention here, which specifies things that like your raw data is immutable data. And in this case, our company's reviews and shuttles data will sit here. But generally we recommend that, like even if you're working from S3 or zero blob storage or something, that you structure your folders the same way because it keeps the convention and what you would expect each different type of data processing to have happened during the different levels that you move. We also have a docs folder. If you're using doc strings in your Python functions, Kedro will use things to generate your documentation for you. We have a folder for logs. This is where we support Python logging, so your logs will go there. There's obviously a place for your notebooks still in this project template too. And then the really important folder is source. So source actually becomes the Python code that you wrote in those Jupyter notebooks. That's what we're interested in here. And remember, in that case, we had two notebooks that we were interested in, a data processing one and a data science one. So let's go into data processing and have a look at what is happening here. So we have our Kedro nodes. In this case, they are the utility functions or helper functions that we had. And then we had three functions below it: pre-process companies, pre-process shuttles, and create model input. I'm going to show you what it looks like now in Kedro when we actually go through the pipeline.py. So I'll show you that now. So if I want to combine these ones into a workflow, I'll take the function pre-process companies. I'll use its input, the companies table called from config, right here. Here. Okay. My output will be pre-process companies, and I'll just call the node pre-process companies node in this case. I'll do the same with the shuttles table, and then I'll create my model input. And here's what it looks like, because now you can actually visualize your workflow. I'm just going to run Kedro Viz and show you what this looks like. Let's open here. So here are those three tables: companies, shuttles, and reviews. There was the pre-process companies node, the pre-process shuttles node, and the create model input node that created our model input table. We knew we had some sort of data science parameters. We mentioned there's column names that we were interested in from our table. The fact that we're interested in, we had random state and a test size as well. And then we split our data and we were able to do things. And you get this view for free for the first time with Kedro. So what I'll do is I'll stop here. Maybe I'll do a Kedro run as I talk through the rest of the stuff you might be interested in. So yeah, essentially Kedro now helps with this reproducible workflow. As you were able to take your Jupyter notebooks and refactor them in different stages, you eventually get down to something that you can use in a Kedro project. But we do always recommend actually starting off in your Kedro project. I mean, there is support for Jupyter Notebook if you were going to be using that, and it's much nicer, a much nicer experience within Kedro, because you can interact with config directly, for instance. So the proper way to actually interact with a Jupyter Notebook in Kedro, if you're interested, is maybe actually best shown through our documentation. So this is using Kedro with IPython and Jupyter Notebooks or Lab, whichever you prefer. And what you find is that we have our own CLI commands for interacting with opening up those sessions. So you'd run Kedro IPython, or you'd run Kedro Jupyter Notebook down here. And you'd see it's a simple matter of just running catalog.load because Kedro knows where your configuration should be. And you get to interact with your data up front like this once it's specified in configuration for you. So yeah, that's the ease of starting with Kedro in your Jupyter Notebook workflow. You also will see that example of the tutorial is taking you through. Kedro Spaceflights one is right here. It'll get you acquainted with beginner to intermediate functionality quite quickly in Kedro, and show you what a typical development workflow will look like. Set up the project template, set up where you're getting your data from, create your pipeline and package your project, and then visualize it at the end. So yeah, shout if you have any questions, and I'll talk to you soon.